The Earth, the planet that we know so well, lying just under our feet, and 160 million miles away, its mysterious sister, Venus. Today, scientists are looking at the future of Venus exploration with excitement. They are convinced that the answers to their remaining questions are soon to be found.
Venus and Earth are very different today. The climate they've ended up with is very different. And one of the main differences you can see behind me, water. Liquid water, we have lots of it all over the surface of the Earth, whereas on Venus it's too hot today to have liquid water. It's 450 degrees on average at the surface, and that's far too hot. But a long time ago, when the planets were forming, they probably weren't so different. The planets were formed, the terrestrial planets, Earth, Venus and Mars, were probably formed around the same time out of the same materials. And initially when they formed, they would have had a magma ocean due to all the heat of formation. And eventually that magma ocean would have solidified so that you have solid rock surfaces, solid rock crusts. But at that point, it's still very hot. You still have atmospheres mostly of carbon dioxide and lots of water in the form of steam because it's too hot to have liquid water. And on Earth, it cooled just enough to allow that water to liquefy on the surface. And once you have liquid water on the surface, then through various reactions, that liquid water can react with the carbon dioxide in the air and with various rocks to lock that carbon dioxide up in rocks, carbon-bearing rocks on the surface. These are things like limestones, chalks, which you find all over the world. And because of that, we're left with very little carbon dioxide in the atmosphere. Happily, because carbon dioxide, for example, is poisonous to us. So this story about the history of water on Earth, the history of the climate on Earth and Venus and terrestrial planets in general, and how unusual it is to end up with such a perfectly adapted planet for us, is something we're really interested in finding out, particularly now that we are aware and we know that there are thousands, millions, billions of planets in the universe. How many of those are going to be Earth-like? How many of those are going to be Venus-like? How many of those are going to have liquid water on the surface? So by tracing the differences in formation and evolution of Earth and Venus and Mars and comparing them, we can find out how unusual it is to end up with planets like the Earth.
To our current knowledge, no other planet offers environments as diverse as those of planet Earth. To continue making progress in Venus exploration, scientists need new ways of investigating. But what are their choices? For Arnaud Mailleux, from the Royal Belgian Institute for Space Aeronomy, the answer is clear.
The best way, but it's usually quite hard to get, is to have new missions to the planet. That's usually the best. You can either do measurement from the Earth, but the problems of doing measurement from the Earth is first, there is a very good point from ground-based measurements is that you can do it as many times as you want, as long as Venus is in the sky. But we are very far away from Venus, so we do not get very localized measurements. The measurements we get usually cover large regions of the planet. The best way is to send, of course, another spacecraft. That's really exciting. That's really something we are looking forward to.
For me, one of the main important things that we will have to answer in the near future is really, can we prove that there are volcans and active volcans on Venus? And to do that, the problem is that we have to look below the clouds. And the clouds are effectively absorbing a lot of light. So you need a specific instrument to look below, look at specific wavelength to go down. And that's something that we are very interested in. We are in the process of developing a new instrument based on SWAR, based on the instrument that we have developed for Venus Express, so building on heritage, but looking down and below the clouds. We are preparing it to be ready for the next call, the next proposition to go to Venus.
Going back to Venus with a new space mission. This is in the mind of every Venus scientist. To discuss this, and all things Venus, a world conference has been organized in Oxford University, gathering for 5 consecutive days the best experts from around the globe.
So here we are at the Venus 2016 conference in Oxford. We are now in the Museum of Natural History of Oxford University. We're 2/3 of the way through. We've heard some great results about which is still coming from Venus Express. We heard some new results from the Akatsuki mission, which has just arrived at Venus, and it's only just started taking science results. And none of those results are publicly released yet, so we feel really privileged to have seen some of those first images.
We Japanese Akatsuki team has a very strong relationship with the European Venus Express team. And actually, Venus Express and Akatsuki are a kind of twins. And so we can continue this collaboration. Venus Express is a polar orbiter, but Akatsuki is an equatorial orbiter. This is very similar to the meteorological satellite of Earth.
So what can we expect in the near future? We have two excellent proposals from our NASA colleagues for the Discovery round. And those proposals, one of those is focusing on the surface science, on mapping the surface with excellent resolution. The second proposal is focusing on the measurement of the isotopes of the noble gases, which will open the door for understanding of the history, not only Venus, but of the entire inner solar system. So I think that these things are definitely, if even one of those is going to happen, then Venus community will be absolutely happy and will really be looking forward for new results and new discoveries.
Dans ce musée merveilleux, on peut voir de nos propres yeux que la nature est variée. Elle est faite d'oiseaux, d'animaux terrestres, de poissons. Une planète, c'est extrêmement complexe également. Il y a l'atmosphère, il y a la surface, il y a l'intérieur, le volcanisme. Donc nous pensons que la prochaine étape de l'exploration de Vénus, après cette très longue mission, cet extraordinaire succès sur l'étude de l'atmosphère, devrait plutôt se consacrer à la surface et à l'intérieur. Donc c'est un petit peu la nouvelle étape. Poursuivre cette exploration, ce décryptage de notre voisine par tous les moyens possibles. Venus Express, à la surprise générale, en quelque sorte, a relancé de manière extrême l'intérêt pour la planète Vénus. C'est une mission extraordinairement à succès. Et finalement, cette opération a déclenché un véritable engouement pour cette planète pendant 10 années. Et aujourd'hui, on a une très très forte communauté et ça a déclenché une sorte d'éveil, d'intérêt international pour la planète. Au Japon, il y a une mission actuellement en cours d'opération autour du Japon. À la NASA, des appels d'offres qui ont été pour l'instant presque à succès, puisqu'on est présélectionné pour aller... Donc il y a eu un effet, je dirais, de boule de neige. Et nous sommes très heureux que l'Europe ait pu contribuer à cette relance pour plusieurs décennies, nous l'espérons, de l'exploration de Vénus.
From now on, nothing can stop the march of science towards Venus. Little by little, scientists are lifting the veil on this little dot that we see in the sky every morning and every night. What does it take to be Venusian? The answer could be patience, ingenuity, imagination, and an insatiable hunger for understanding what is beyond our world.